All right, it is 11 o'clock. The next example that they have in here talks about aggregation. And to just look at it, think about it this way. If you go out to here, if you go out to courses.blackhawk.edu, and if you don't know this, come next Monday, you can go out there and start registering. All right, but let's say that I want to, and it's going to be for fall, and I'm going to put in here 152, 145, which is the advanced Java class. So I click submit. All right. This is the course. The course has got a bunch of stuff in here. You know this already. That if I click here, I can get the description, etc. All right, but the key thing to some people, is who the hell's teaching it, and what book are they using? Now, you know you don't have another book for the advanced class because we're using the same book. But the point is, you know, the things that are to some people that are most important when they take a class is, you know, you need the course number, etc. But who's teaching it and what's the book? All right. So why did I just mention that? Because that's what they start talking about in here. What they're going to do is they're first going to build an instructor class. All right. Then they're going to build a textbook class. And then they're going to build a course class. And the course class will consist of some stuff, but it will also consist of an instructor class and a textbook class. That's aggregation. When you go and create classes, and those classes become components of other classes. Very similar to what I mentioned to you before, that if I was going to create a car class, I might first create a tires class and an engine class and a whole bunch of other classes. And I want to do those first so that when I get to the car class, I can drop those in as components, or also known in this case as aggregates. All right, so that's what they're talking about here. It says you decide to create a course class that'll have the following information: the name of the course, the instructor's last name, first name, and office number, the textbook title, author, and publisher. All right. So they go through the UML and they show you what it's going to look like. But basically, this is the instructor class, rather. So an instructor, as it says there, will have a last name, a first name, and an office number. In the constructor, you'll set all those. And they also have in here a copy constructor. All right? And think about why you might want to do that. If it's the same course, isn't the last name of the instructor, the first name of the instructor, and the office number of the instructor going to be the same every time? At least I think it is. What's different for me every semester are those of you who sign up, so that's the students. All right? But it's not the instructor that changes. So they show that in here, where they have a copy constructor. Then they've got your typical sets. Okay? And notice here also they've overridden the toString method. This is the kind of thing, again, that we're going to do on Wednesday. We'll talk about that before the end of the class today. So far you've got something that looks like this. Remember, this is a UML diagram. That's the name of the class. In the second of the three parts of your rectangle here, these are the name of your instance variables. All right. Title, author, and publisher, they each have a minus in front of them, meaning they're all private. And here are your methods on the bottom third. They all have a plus in front of them, meaning they're all public. The first two, textbook and textbook, are the exact same name as the class name. So in other words, those are constructors. Then we've got a set and a toString. All right. Then we do the same kind of thing with a textbook. So I don't really want to go over it because it's very similar to what we just saw for the instructor, but it's a textbook. So we do the same kinds of stuff. Then, so there's the UML for that one. Looks very similar to the one for the instructor. Then we create the course. This is what's new. These two lines, you've not used something exactly like that before. Because what we're saying is private textbook, that's the name of the variable, but it's of type textbook. So a course class has as components a course name, which is a string, an instructor, which is an entire class, and a textbook, which is an entire class. All right? And if that doesn't really make a lot of sense to you, go back, please, and read the chapter. All right? Now, this runs into all sorts of issues when you do this. First of all, you end up with something that looks like that. All right? And what it says is instructor and textbook are components. That's what that open diamond means, of course. All right? But the big thing here, and as always, he's got it right at the bottom of the page, so that's about as far as down as I can get it, is as it says, when you're using aggregate classes, you can create what are called security holes. And all the author is trying to say here is make sure when you do it the right way. All right? So, it says we will focus on 2 specific practices that help prevent security holes in your classes. Number 1, perform deep copies when you're creating objects. All right? And what that means, to keep it simple, don't copy addresses, copy contents. Does that make sense? Don't just work with addresses. If all you're doing is copying addresses from here to there, you're doing what's called a shadow copy. All right? But if you copy what's the inhabitants at that address, it's more work, but you can be assured that it's going to be more successful. So if you only copy the addresses, it's a shallow copy. If you copy the inhabitants at that address, it's a deep copy. You always want to do deep copies. That's what the author's saying, first of all. All right? But when you're working with these, it says when you return a reference, return a copy. Don't return the real thing. All right? And he explains this in more depth and breadth of coverage. But the idea is that if, when people come in and, when hackers and stuff come in and try to do things they're not supposed to do, in some languages, what they try to do is they try to, as much as possible, is to get a hold of the source code. All right, I'm not going to go into a security thing here, but the idea is sometimes when they're looking at the source code, they poke around, they might be able to get an address of something. And if all you're doing is working with addresses and they can go in there in their code and change those addresses, you're going to be hosed. But if instead of the addresses, you're copying what exists at those addresses, you'll be better off. Now, again, if somebody breaks into the system and does all sorts of damage, it might not matter whether you do a deep copy or a shallow copy. But all you can do as a programmer is your best to try to make sure that if there is a security breach, whatever is breached is as minimal as possible. And this is one way of doing it. And that's what the author is explaining in here. Again, probably much more eloquently than I just did. All right, and here he explains why you should return copies. Okay. It says, notice the return uses the new keyword to create a new instance. The object that's created is a copy. The address of the copy is preferred. This is preferable to returning a reference to the field object itself. And the reason for that is, just in case in this method, you screwed it up. So you're returning a copy, not the original. And that's what he's getting to in here. All right. We may or may not have talked about this before. See that line of code right there? All right. If I put a brand new line in, I can't do it here, of course, but if I put a brand new line in between lines 9 and 10, so I just said right there in line 9, private string last name. I put in a brand new line 10 that says system.out.println, and I put in their last name equals, and I try to print out last name. Is it going to work? No. What am I going to get? You may have gotten this already. If you ever try to run a program and you got an error message, you get what's called a null pointer exception. Because right now the value of last name is null. So the system is trying to tell you, if you ever go and you run your program and you get an error message where you're looking down in your window at the bottom of the screen and it's in red, that's called, that shows you a stack backtrace. But if you get that in there and you get a null pointer exception, that means you're trying to print out the value of some kind of a variable before you've set its value. All right, and that's what he's trying to talk about in here. He shows you a little example of it, but that's pretty much what it is. All right, so how do you make sure that doesn't happen? You check to make sure something is or is not null. And it's something you should get used to doing in virtually every programming language. In fact, John will attest to this, I think, that when you work with iOS, when you're doing stuff for iPhones and iPads and you're using Swift, it's one of the most literal languages I've ever seen, and it will not allow itself to be confused like this. All right? So yeah, you can make checks for this, but in there they don't call it null, they call it nil, and you end up using it when you're creating variables. A lot of times you end up using question marks and exclamation points. All right, we'll talk about that, but it won't be till next semester. All right, the this keyword, we've used it before, and we've always talked about stuff like this. If you do this, right there, what you see in blue, notice you don't need the word this because the actual name of our variable is symbol, but we're calling it sim here. The actual name is share price, but we're calling it price. But if you call them and pass them in as the same name as their quote real names, you need to use the word this. Just so you know, the program will work fine in here if you still put this dot in front of all those. Many Java programmers always put this dot in front of everything inside of a method, whether they're using the same name or whether they're using another name. They don't care. All right, but this is that shadowing, because if you leave the this dot out of there, it probably will give you at least a warning, but it's not going to copy it. It's going to make a copy of the copy, so it's going to make a copy of that and copy it to itself if you leave the this dot out of there. All right. When the system is confused, as it says, if you're calling you're one thing and you're calling another, you can put this in there. Much of the time, you could put this or this dot when you're doing almost anything. This is a little bit more advanced concept. All right, then enumerations. We can go through them quickly because Damien said you all know what they are already. All right, so here's how you set up an enumeration in Java. It's a brand new data type. It's a user-defined data type that's called day, and its values are Sunday through Saturday. Since we didn't give this an initial value, Sunday is equal to 0. So again, I can come in here if I want to. I can come in here and do this. Now Sunday is 1, Monday is 2, Tuesday is 3, etc. All right? I don't have to do that, but if I leave that off, now Sunday is 0, Monday is 1. So a lot of times, especially when you do this, and you've got months, and you've got January, I'll just put in January, etc. They'll say equal 1, etc. So you're sure that it's the month number that you're used to using. All right. But even if you do something, for some reason, if you do this, and you can, so I can say in here February equal 27. I don't know why I would do that, but you can. Now if I put in March, it automatically goes to 28. So you can do that. That works the same way in C#, just so you know. You typically won't want to do that, but if for some reason I was creating an enumeration and I wanted it to have only odds, I'd have to put in here equal 3, equal 5, etc. All right. Now, you never have to use these, but when you do, I just want to show you most often why you'd use them, because they give you examples in here, and that's all fine and dandy. But typically, the reason that you'll use these, I'm jumping up a little bit, there we're creating a brand new file. That's an actual Java file. It's an enumeration. And we're saying enum car type Porsche, Ferrari, Jaguar. And you create that so you can do Come on. This. Because it's more English-like to say case Porsche, whatever the hell it is. So you usually create enumerations so that when you're actually going in and you are, when you want to do switch statements or other types of code, the code becomes more English-like. Because right here, unless you knew that 1 was a Porsche, 2 was a Ferrari, 3 was a Jaguar, etc., you might be confused. All right, the garbage collection we've hit on already. If you want to make sure something is set up to be garbage collected, that's what you do. Whoops. You take the variable and you set it equal to null. That's like you automatically putting that line under the tire. That doesn't mean the meter maid's going to check it then. But what you're saying is, okay, you know, now when you check it, now what you're basically saying is this isn't being used for anything anymore. You should always do that because otherwise you're just wasting memory. People will say, well, yeah, but I got all these gigs of memory. So what? You got all these gigs of memory so you can put all those movies and all those songs and all that whatever on there. All right. And the last thing that's discussed, I mentioned this finalized method. Typically, even though there is a destructor that's never called, if you want to do something that's final cleanup, typically it's done in a destructor. I'm sorry, in a finalized rather method. All right. And the last thing they talk about in here is on what are called class collaborations. So they've got an example in here, but let's just jump to the chase here. And the author says you can use these CRC cards. C, the first C there is this. It's the name of the class. The R that's in CRC, so the C class, the R is responsibility, and the C is what class do they have to talk to. Sometimes people find it easier to write up stuff like this. All right, you don't have to, but sometimes people do. All right, what I'm going to ask that you do, I mean, it's hot in here, so if you want to leave, because I'm finished the chapter, but I want to show you what we're going to do next time. We're going to go over this program right here that unfortunately is broken up over 2 pages. We're going to go over this month class that you see on 555. Write a class named month. It should have an integer field named month number that holds a number for the month. All right, January's 1, February's 2, etc. We could even create that as an enumeration if we wanted to. All right. Then notice we're going to have a no-arg constructor. We're going to have another constructor. We're going to have another constructor. We're going to have a set month number, a get month number, a get month name, and we're going to overwrite toString. We're going to have our own equals method. And then we're going to have a greater than method, and we're going to have a less than method. So you don't have to do it at this minute, but what I'm going to ask that you do between now and, because I'm going to jump right into it in the next class, is to start up a new Java project. Just call it month. All right, and if you want to go out to the P drive, you know the drill. You go out to the 143 class and you go out to the homework folder, there is a thing in there that says someplace, Chapter08, 05, month class. That's got the whole comments that are in there, if you want to drop those off at the top. So I'm going to have mine built, so when we start next time, I'm going to have that. You know, you don't need to worry about a main, because we'll write a separate class for that. But create a brand new project. You can call it month, you can call it whatever you want, but then inside the class that's going to be in there is going to be called month. Does that make sense? So that's how we're going to start up next class. And if you've got that done, that'll save us 10 or 15 minutes probably. But make sure that you have Eclipse up and running and you have that project started, because that's where I'm going to be. And the minute we click the 10 o'clock, we're going to start it. All right? That's all that I have.